All right, number 16, we want to determine the location and value of the absolute extreme values on f on the given interval if they exist. Okay, so first we want to find the derivative. Bring this down a little bit. We have f of x equals 2 secant x. And we are on the interval pi over 4, negative pi over 4 to pi over 4. So again, the process is find the derivative, find the extreme points, and we're going to test those extreme values in the original function as well as the endpoints, and that will give us our max and min. All right, so we're going to find the derivative. Now, some of these trig derivatives you might commit to memory. Some of them we'll just refer back to our trig cheat sheet. This one I want to show you, there's two different iterations. They're both equal. But if I go back to our course and our homework videos, we have cheat sheets and handouts. So there's two documents. There's derivatives cheat sheet, and then there's the differential. So if I go to the derivatives and we find the derivative of secant. Okay, so this iteration of secant is showing us tangent x divided by cosine of x. All right, so that's one possibility. The other differential sheet, this is one I'm more used to using. Okay, gives you a different simplification of it. So this one is giving derivative of secant is secant x times tangent of x. So remember, tan is sine divided by cosine, or just tangent, and then 1 over cosine is secant. So they just rewrite that 1 over cosine, or the cosine that was on the bottom, as secant. So they're both the same, so just be aware. I'm going to use the secant tangent definition for the derivative. All right, so when I do f prime, this is going to give us, now this coefficient can come out front when we do derivatives. So this is going to be 2 secant x tan x. So here's my derivative. We're going to set this equal to 0. Divide by 2, so that'll give us secant x tan x. And then pretty much, since we're multiplying, that multiple theorem says that this expression will be equal to 0 if secant is equal to 0 or tan is equal to 0. Now, secant, it's not possible for that to be equal to 0 because, again, that comes from 1 divided by cosine of x. And if cosine of x is 0, we will be dividing by 0, and we cannot divide by 0. So this one cannot be equal to 0. Not going to get any critical values from that. However, tangent can equal 0. And again, remember, tangent comes from sine divided by cosine. Now, again, cosine cannot be equal to 0. We would be dividing by 0. However, if sine is 0, 0 divided by any number is going to be 0. So we're going to look for the values that make sine 0. So again, if I refer to our unit circle, the y value is 0 at every interval of pi. Now, our restrictions limit us to be between negative pi over 4 and pi over 4. Okay, so starting at 0, if I went backwards counterclockwise, negative pi over 4, that would be clockwise. But going backwards for the unit circle, this would be negative pi over 4, so that would be this angle. So we're between here and pi over 4 here. So we do get that angle 0 that lets tangent be equal to 0, 0 divided by 1. So this is going to be equal to 0, again, you can do the math. If you set it equal to 0, multiply sine x is equal to 0. If you do inverse sine, that's when x is equal to, that would be the angle 0. So we get one critical value. We're now going to plug in all three of these to secant and find out which one gives us the largest and smallest value for maximum and minimum. So we're going to do f of x. And we're going to do 2 secant of negative pi over 4. We're going to do 2 times secant of 0, and then we're going to do 2 times secant of pi over 4. Okay, so I'm going to do some mental math, but I'm just going to kind of show you what's happening. Secant is 1 over cosine. Okay. So I'm taking the cosine value, and then I'm going to flip it to invert it. So this is pi over 4, sorry. So if I go to the negative pi over 4 angle, that would give me this angle here. Cosine is referring to the x coordinate, so that would be square root of 2 over 2. So this is going to come out to be 1 over square root 2 over 2. And then if we flip that, keep change flip, we would just get 2 over the square root of 2, which we don't like square roots on the bottom. I think you can leave it like this. For the system, it'll take it. But if you want to rationalize the denominator, you can write it as 2 square root of 2 divided by 2, which will cancel out and just give you square root of 2. I believe that's right. Square root of 2, square root of 2. Yeah. And we can verify that those two are equal. Usually there's no way to really see it, but you look at the decimal formation. So if we look at 2, well, yeah, I want to do 2 divided by square root of 2. And then if we just type in square root of 2, because that's what I'm saying, it simplifies to. You just look at the decimal iteration, you see it gives you the exact same thing. So 2 over the square root of 2 is the same as just the square root of 2. Even if you wrote it as 2 square roots of 2 over 2, it will give you the same thing, 2 square root of 2 divided by 2. I should have put that in parentheses, but I think it still works out. Nope, it's not. I need to put this in parentheses, sorry. Because that order of operation is going to take over, and it's going to only divide the square root of 2 by 2 and then multiply by 2 at the end, which that's not what we want. Put parentheses there. And close it there. So that's the way that we rewrote it. So you can see all of them match. So you can verify that that's the same. So if I was to plug in cosine of 0, cosine of the angle 0 is going to give me the x value of 1. So I'm sorry, I'm making an error here. That's giving me square root of 2, but I need to multiply this 2 by it, because that's all we've done is this part. So we've got to multiply this by 2. So this should be 2 square roots of 2. This one, whenever we plug in 0, will give us 2 times 1, which would just give us 2. And then when we plug in pi over 4, it's going to give us the same value, square root of 2 over 2, which will give us 2 square roots of 2. So these two come out to be the same, 2 square roots of 2. And then this one comes out to just be 2. Now, obviously, or hopefully you can see that 2 times some number is going to give us something bigger than 2, as long as that thing is greater than 1. If it was a fraction, it would be smaller. So the pi over 4, negative pi over 4 are the same. This 2 is different, but this 2 is smaller, so it's going to be my minimum. These 2 would be my 2 maximum points, would be the same. So we are going to say the absolute maximum is blank at x equals, and the absolute minimum is, okay, absolute minimum. Okay, so A looks like the best answer choice. Absolute maximum is going to be 2 square roots of 2. And that occurs at x equals, we're going to say, nope, in the wrong box. X equals, okay, why does it keep doing that? Pretty sure I clicked in this box. Not sure why it keeps going back to that box. It occurs at x. Okay, there we go. At negative pi over 4 and positive pi over 4. Both of those endpoints give us the same, and our absolute minimum is 2, and that happens. 2 occurs when, what was that critical value? When x was 0.